All right, so now we are going to start talking about trigonometric graphs. And so we're going to start with sine and cosine. That's our learning target. So how do we graph these? One thing that you will need for this is your unit circle. So you should already have that. If not, I will put a completed one into Schoology that you should definitely download. Okay, so when we graph these are going to look like waves. And you'll see why in a minute. But there's some things that we need to know. They're called periodic functions. These functions repeat exactly in regular intervals. They keep doing the same thing, and these are called cycles. So trigonometric functions are periodic, okay? The period is the length of a cycle. So for example, if I look and I start, you can kind of see here, from this point to the exact same spot where I get there again, how long does that take? So that is called a period. And you can really say any point in here, I could say from here to here, that period should be the same, okay? So really any spot that you see is convenient, but this is called a period. So that would be the length before it starts to repeat, okay? And then another term that you're going to hear a lot is amplitude. The amplitude, you can see down here at the bottom, it says half the distance between the minimum and the maximum values. So the minimum value would be down in right here. This is as low as it goes, and this is as high as it goes. So the amplitude is in between that, okay? So either, they point to this distance here, but it might be easier to say from here to here. How low is that? Or I generally say the height, like from the middle to the top. That's kind of how I usually look at it. But that either way you look at it, it's from the midline to the top or the bottom, the max or the min, and that is called the amplitude. Okay. So these are some terms that will come up quite a bit. You'll get used to them. All right, so we are going to graph sine. What does this look like? Now, you'll notice here I have the unit circle on. I also have my graph is on the y-axis. It's just regular 1, 2, 3, 4, 5, and negative versions as well. But on the x-axis, it's in radians, and it's in terms of pi. And the reason is, you're going to see here in a second, we're going to use radians to go around, and we'll look at the how this all manages and functions. But here we go. We'll just get it started. So remember, in the unit circle, sine is y. Okay? So when we're looking at sine, we're really looking over here at these red values. So we're going to start with 0 radians. Okay? So 0 radians right here. What is the value of y? It's 0. So how do I plot that? Well, at 0 radians, the output, it's 0. So 0, 0. Okay, now we can go to these other values like pi over 4, which each one of these squares represents 1/4 pi. But I'm going to go to a half pi because it's a little easier to utilize. If we look at a half, the output at a half radians, it's 1. So on my graph, I'm going to put at half radians, pi over 2, it's 1. And I'm just going to continue to work my way around this unit circle. And so I'm going to go to pi here. Now, if you go here, 3 pi over 4, you're going to get square root of 2 over 2, which is about 0.7 something. So you'll notice that's not a super nice number to deal with. So we're going to kind of stick with easy ones. But this would be at pi is going to be equal to 0. Okay? And then we're going to go down to 3 pi over 2. And you'll notice it's negative 1. So I'm going to plot that. Okay, now if I go to 2 pi, back to 2 pi, remember this is 2 pi right here. This is back to 0. And I've completed one cycle. Now, this will continue because now I'm going to continue back around. I'm just going to keep going around and around, and it's going to repeat, right? Because those same values will stay there. So now that's what I have. You can kind of see it's a wave there, and that will really continue. But now let's just go the other way so we see what's going on. So let's say I went negatively around. I went this way. Okay, at negative pi over 2, that would be at negative 1. So this would be negative 1. Okay, now if I continued and I went to negative pi, that's back to 0. Okay, you can just see this wave is continuing and it's going just the other way around, but it's the same cycle. And so this would be at negative 3 pi over 2. We are at 1. And then all the way around at negative, we should be at to 0. And sure enough, so this would be 0. Okay, now what you want to do is you want to connect this with a smooth curve. It's a wave. Don't do that. It's a wave. It should be a smooth curve. It should not be straight lines. So I'm going to do my best here to make that happen, but okay, now I'm going to put arrows because this just continues to repeat. So this is what sine looks like. Now, what is my amplitude? Well, you'll notice I'm going to get rid of some stuff here. We got a lot of stuff going on. My amplitude is the height. So you'll notice the highest it gets here is 1 or negative 1. So it goes up to 1 or negative 1. From the midline, it goes up 1 or down 1. So that amplitude is 1. Now the period is how long does it take to repeat a cycle. So really, this probably will make sense. We start at 0 and it's increasing. So where do I get to 0 and it's increasing again? I got 0 here, but it's going down. So not there. So really, I get back to 0 where it's increasing again right there. So how long does that take? Well, 2 pi, right? So I have from here to here, that's one cycle or one period, and that's 2 pi. And that shape that you see there is really important. So this is 2 pi, okay? All right. That's the period. And again, starting at 0, going up, down, and coming back to 0. This kind of shape is pretty important to keep in mind for sine. Okay, cosine. Cosine is very similar, also a wave, as you might expect. Okay, so what does cosine look like? Cosine, remember, in the unit circle, is x, okay? And so when we're looking at this, we're really looking at the blue values. Now, as I start at 0 radians, I start at 1 this time, not at 0. So that's a key difference, as I'm starting at 1, okay? And then now I'm going to go around, and I'm going to go here to pi over 2, and you'll notice my x value there is 0. Okay. And then if we go to pi, we're at negative 1. Three pi over 2, we're back to 0. And then 2 pi here, that would be at 1. Okay, now if I go back the other way, You can see that's one cycle there, and then I would begin to repeat. But if I go back the other way, this is going to do the same thing, right? If I go this way around, okay, I'm going to start at negative pi over 2. That's going to give me 0. Right, and then at negative pi, I'm at negative 1. At negative 3 pi over 2, I'm back to 0. So you can see, and then negative 2 pi, I'm at 1 again. So once again, here I have this wave situation going on, and I'm going to connect these with a smooth curve. It's a little smoother than my other one. But really, what is the amplitude now? You can see here, we're still having an amplitude of 1. Okay. Now, my period, this time, if I start here, where does it get to that same spot? You can see right here. What's the period there? That's a length of 2 pi. Now, you can figure this out any spot you want. Remember, it can be anywhere you choose. I just like to choose starting at 0, but that doesn't really matter. If I started here to here, notice that's a length of 2 pi as well. So any time it repeats, that cycle is always 2 pi. Okay, so that is the cosine function. All right, hopefully that makes some sense. So how do we change the amplitude and the period of these? Well, the amplitude will be whatever number you see in front of here. You'll see a number, that's your A. The absolute value of that, if it's negative, you'll make it positive. The absolute value of that is your amplitude. You can also change the period of this, the length of the cycle, and by changing this number in front of theta, that's B. Whether it's sine or cosine, it's going to be the same. So then how do you figure out what the period is? We know that the period for both sine and cosine is 2 pi. So you're just going to say 2 pi divided by B. And that's how you can change the period of these. So for example, if I said, if I looked at this and I said 3/2 times sine of 1/3 theta, what's the amplitude? Well, the amplitude is my A value, which is that right there, 3/2. And then my period is going to be 2 pi divided by B. In this case, my B is 1/3. Okay, so I would say, all right, well, what is that? Now, remember how we divide fractions, we multiply by the reciprocal. So I would multiply this by the reciprocal, and that would give me 6 pi over 1, or just 6 pi. Okay, cool. So that is my amplitude and period for that function. Okay, here's another one. What's the amplitude? It'd be 3. What's the period? I'd say 2 pi divided by B. B is 2. So this would be 1 pi. Okay, that's how you change the amplitude and the period for sine and cosine functions. So let's take a look. All right, so when we do this and we graph, how does this all come together? Well, my amplitude here is 4. Okay. My period is 2 pi divided by 1. So this hasn't been changed. The B hasn't been changed, so it's still 2 pi. Okay, so what does that mean? Well, I know what the sine function looks like. I know that the sine function starts, remember this is kind of easier to think about. Sine starts at 0. Oops. Starts at 0 and goes back to 0 at 2 pi. So I want to get that one cycle. Really, the only thing here that's changed is I'm starting at 0. I know I need to get to 2 pi back to 0. Okay, now the only thing that's different is the amplitude is going to be different. It's going to go up to 4. So rather than going to 1 here, I'm going to go all the way up to 4 at pi over 2. Remember, then this comes back down to 0 at pi, halfway in between. And then I'm going to go down to -4 right here. Okay? And I've created one wave. Now I just repeat that and go back the other way. So I'm going to go back here. This would be at -4, 0, 4, 0. And I'm just going to connect these all together. So here we go. All right, and that we've just changed the amplitude. So now that's a wave. It's just now a little bit taller wave, right? Okay. Now we can adjust the period too. So what does that look like when we do that? Well, here the amplitude hasn't changed. Notice the number in front here still is 1. I'm going to switch colors. So the amplitude, 1. The period is going to be 2 pi divided by 1/2, also known as 2 pi times 2 over 1. So this period would be 4 pi. Okay, so now I want to use that. All right, well, I know that cosine now, remember cosine starts at 1, and my amplitude is still 1, so I know I'm going to be here. And now I need to get back to here. It kind of goes, if you remember, cosine kind of goes like this. So I need to get back to 1 at 2 pi. But now it's been changed to 4 pi. Okay, so weird. So I know here that this is now going to change to 4 pi. Well, halfway between would be 2 pi then, right? So that's really what at 2 pi now, I should be down at negative. So normally it would be halfway would be right here. I'd be down to -1. Okay, I'd be at 1 there. It kind of look like that. But what I need to do now is change that and make it more stretched out. So I'm starting here, and I need to, 4 pi is way out here. So halfway in between that, I should be down in the middle at -1. So that's 2 pi. Okay, so that is, my whole wave is not there. That's okay. So halfway in between that, then I should be right here. Okay, so this would kind of go, you know, like this, but I'm not going to be able to see that on this graph. So now I'm going to go back the other way, and it's going to repeat this cycle. So now notice from here to here is still 4 pi, and that's one cycle. So that's what I can fit on this graph, and sometimes that's what you're going to see. Okay, so there we've just done cosine of 1/2 theta. All right, so let's keep going on this, and hopefully this will make some sense. We're going to kind of put this all together and see if you're on the right track. Okay, so now this one we've changed the amplitude, we've also changed the period, and it's a sine wave. Okay, so what is my amplitude over here? I'll pick a different one here. Okay, my amplitude is 5. My period, well, let's see, it's 2 pi divided by 1/3. Oh boy. So this is going to be 2 pi times 3 over 1. That's going to be 6 pi. Okay, so here I'm going to have a really big stretched out version, and that's okay. We'll figure it out. We know that sine starts at 0, and that's still going to be the case because if I multiply by 5, it's still going to be at 0. Now, sine, remember, goes like this. Okay. So that's usually 2 pi. Now it's out to 6 pi. So halfway, I'm in the middle. Well, half of 6 pi is 3 pi. Well, that's still not on my graph. Okay, so half of that, so a fourth of it, I should be at 1. In this case, I would be at 5. Okay, so if I take this and cut it into a fourth, well, half of 3 pi is, or half of 6 pi is 3 pi, cut that in half, and I would get 1.5 pi, right? Half of 3 pi, 1.5 pi. So that's right here. So I should be at 1, but now it's been amplified to 5, so I'm all the way up here. Okay, and then now if I continue that, I would come down here, but I don't have room for that. So I'm going to go the other way and just say at negative 3 pi over 2, I should also be at negative 5. And really, that's all I got room for. Okay, so I'm just going to kind of start my wave here. And that's not very good, actually. Let's try that again. Okay, that looks a little more like a wave. All right, so that's all I can fit on this graph. These can be a little tricky to get the hang of, but ultimately that's how they work. You'll get more and more practice as we go, and we'll continue with this next time. But hopefully you're starting to get the sense of this. We'll try some more, and you'll get a little bit better with how these work. All right, take care. See you later.